another rational equation. In this rational equation, we have a little bit more complicated denominators in two of these fractions. Here we have x squared. Well, if you think about trying to cancel out an x squared, wouldn't you have to multiply by an x squared in order to cancel out the x squared? So x squared has to be part of my least common multiple, the multiplier I'm going to use times both sides of the equation. And then the coefficients, 4, 2, and 4, the least common multiple there is 4. So what I'm going to multiply both sides of the equation by is 4x squared. And that will involve multiplying each term by 4x squared. I distributed the multiplication of 4x squared times each of the terms that were in the parentheses. Now we're going to multiply, and remember, when you're multiplying with fractions, what you want to do first is do any canceling you can do. Well, here, the 4x squareds completely cancel each other out, because remember, this is like having 4x squared over 1. And that just leaves us 1 plus, here, this x. How many x's do we have when we have x squared? We actually have 2 x's being multiplied, don't we? So wouldn't this 1x that's here cancel out one of the 2 that are here, leaving us x to the first? So we have 4 times x to the first, which is 4x. 4x times 2 is 8x. Same thing's going to happen here. This 1x will take one of the 2 x's that are there and cancel it out. And 2 goes into 4 2 times. 2 times x is 2x. 2x times 3 is 6x. And here, the 4x squareds will cancel completely, just leaving us 7. And now we have another nice linear equation we can solve. Let's start that solution by subtracting 6x from both sides. So 1 plus 2x equals negative 7. I'll subtract 1 from both sides. 2x equals negative 8. Dividing both sides by 2, x equals negative 4. We've solved this rational equation by finding the correct multiplier that canceled all the contents of the denominators. That created a nice linear equation for us to solve to get our solution of x equals negative 4.